Today's target will be adding and subtracting polynomials. By the end of today's lesson, you will be able to simplify polynomial expressions by combining like terms. This will be our first polynomial video, so I'm going to go over some terminology, some vocabulary words to know. First off, what is a polynomial? Maybe not be something that you've heard before. Polynomial is a monomial or sum of monomials, each called a term of the polynomial. So a binomial would be the sum of two monomials. A trinomial is the sum of three monomials. So we're going to focus on in algebra, monomials, binomials, and trinomials. When you get to algebra 2, you'll see polynomials with more than three terms. So what do these things look like? Here we have an example of each. First is 5x squared y to the third power. This is a monomial. It is one term made up of a coefficient and variables. Next we have a binomial. It is two terms. It's 2x and negative 5. And then lastly we have a trinomial, which you'll notice is three terms, 4x squared, 3x, and then negative 1. So what we're going to look at today is adding and subtracting polynomials. And the key thing that you have to keep in mind is something that you learned a while ago, and that's that you can only combine like terms. So here in our first example, we're adding two trinomials. The first thing we want to look at is we want to find like terms. So I've got a 5x to the third power. I look around the rest of my two polynomials, and I do not see any other x to the third power. So I do not have any other like terms to pair with this 5x to the third power. So I just write it as it is in my answer. Next up, I have 3x squared. I look over here and I say I also have a positive 2x squared. I can combine these two, 3x squareds plus 2 more x squareds. I'm just going to add the coefficients, and I get positive 5x squared. Keep in mind that when you add polynomials, the exponent does not change. I know we've been working on exponent rules where we multiply x's together and we add their exponents. Here, because we are simply adding the terms together, the exponents don't change. Okay. When we do these problems, we want to keep our polynomials in terms of greatest exponent to least exponent. So we've got a 5x to the third, a 5x squared. Now we're going to look and see if we have any x's. So I've got a negative 6 here. I don't want to deal with that yet. Look over here, and I've got a negative 5x. You'll notice that I'm using different shapes because I want to differentiate my like terms. Here with my negative 5x, it has no like terms, similar to my 5x to the third power. So this comes back, or it comes down, and is going to be part of our answer, making sure that we keep the negative with it because it is negative 5x. So I'm going to write negative 5x as part of my answer. Lastly, I look at my constant terms, or my terms without a variable. I've got negative 6 for the first polynomial, positive 3 from the second. These two combine together. Negative 6 positive 3 gives me a negative 3. So once I've gotten to the point where I have no more like terms that I can combine, I'm finished with the problem. So our answer would be 5x to the third. We have 5x squared from combining my two different x squared terms, negative 5, and then a negative 3 from combining my two constant terms. Let's look at what happens when we subtract. So now we have the subtraction sign in between the two. And here, before we can do anything else, what this subtraction sign does is it changes the signs of all of the terms following it. So I'm going to rewrite this, and it's going to be negative x squared, negative 3x, and then I had a negative 7, so that one becomes positive 7. The first one stays the same. And now because I have changed the signs, I also changed the sign in the middle. So now it's just a simple addition problem. So now I can look back and combine my like terms. I've got a 2x squared, and I've got a negative x squared. Remember that there is no coefficient, it's a 1. So 2 and negative 1 combine to give me 1x squared. You do not have to write the 1, but it's not incorrect if you do write it. Next, I've got a negative 5x and a now negative 3x. That combines to give me a negative 8x. And then lastly, I have a positive 1 and now a positive 7, which combines to give me a positive 8. There's my answer. Okay, so now you have an example of adding and of subtracting polynomials. Key things to keep in mind: number 1, that the exponent does not change when you are combining like terms. Number 2, you can only combine like terms. I cannot combine an x squared term with an x term. That does not work. And then lastly, when you're subtracting, the first thing you have to do is change the sign of everything in the polynomial that follows that subtraction. Well, now it's your turn. You've had 2 examples. Now it's your turn to try 2 examples. You've got an addition problem and a subtraction problem. So you're going to pause the video now and then press play when you're ready to check your work. Here I tried to color code my answers in addition to drawing different shapes, so hopefully you can see where everything came from. Notice number 1, it's a simple addition problem, so we don't have to worry about changing any signs. We're just looking to combine our like terms. In the green, we have the x squared terms, a total of 9. In the blue, we have the x terms. We have a positive 8 in the first and a negative 4 in the second. So we combine those two to give us a positive 4x in our answer. And then in the red, we've got our constant terms with a negative 5 in the first and a negative 9 in the second. Combining those two negatives leaves us with a negative 14 in our answer. Moving on to number 2. This is a subtraction problem, so the first thing we have to do is change our signs. So that second polynomial becomes negative x squared. The negative 2x becomes a positive 2x, and then negative 2 becomes a positive 2. Once I've done that, then I can look to combine my like terms. In the green, got the 3x squared from the first problem, and a now negative x squared in the second polynomial. Those two combine to leave me with a 2x squared. In the blue, I've got the 4x from the first polynomial, and now a positive 2x in the second, which combine to give me a total of 6 x's. And then lastly, in the red, you'll notice that I've got a negative 5 in the first, and now a positive 2 in the second. That will combine to give me a negative 3 in my answer. Well, that's it for adding and subtracting. As always, if you have any questions or concerns, please make a note of them so you can get your questions answered when you come back to class.